This video will cover equilibrium calculations. We will learn to write equilibrium expressions, calculate equilibrium constants, and predict reaction direction using the reaction quotient. We will also learn to solve for unknown concentrations using the ice table method. In this section on finding the balance, we will define chemical equilibrium and discuss the equilibrium constant, equilibrium expression, the law of mass action, and the reaction quotient. To master equilibrium, we need to understand several key concepts. These include chemical equilibrium, the equilibrium constant K, the equilibrium expression, Le Chatelier's principle, the reaction quotient Q, and ice tables and calculations. Chemical equilibrium is the state where the forward and reverse reaction rates are equal. Concentrations of reactants and products are constant, but not necessarily equal. Equilibrium is dynamic and can be reached from either direction. The equilibrium constant, K, is the value of the reaction quotient at equilibrium. It indicates the ratio of products to reactants, and its magnitude reveals the extent of the reaction. Remember that K is dependent on temperature. The equilibrium expression is a mathematical representation of the law of mass action. It shows the ratio of product concentrations to reactant concentrations, each raised to their stoichiometric coefficients, using the balanced chemical equation. Le Chatelier's principle states that a system at equilibrium responds to minimize a disturbance. Changes in concentration, pressure, or temperature can shift the equilibrium position, causing the system to adjust until a new equilibrium is reached. The reaction quotient, Q, is calculated like the equilibrium constant K, but uses current non-equilibrium concentrations. Comparing Q to K helps us predict the direction a reaction will shift to reach equilibrium. Ice tables are tools for tracking concentration changes during a reaction. I represents initial concentration, C is the change in concentration, and E stands for equilibrium concentration. This method is crucial for equilibrium calculations. The key takeaways are that equilibrium is a dynamic, balanced state, and K quantifies the product-to-reactant ratio. Le Chatelier's principle explains system responses, Q predicts reaction direction, and ice tables are used for concentration calculations. To review, consider the factors that disrupt equilibrium and how Le Chatelier's principle predicts shifts. Reflect on the relationship between Q and K, how ice tables are used, and real-world applications of equilibrium principles.